Hi and welcome back to another video. In this session we will be covering matrix multiplications. Now here we have a matrix A which has 2 rows by 3 columns and matrix B by 3 rows 2 columns. Now for matrices to multiply they can't be the same size. There's a rule. Matrix A, let's just say it has m rows times p columns. Now matrix B, let's say it has p rows times n columns. For matrices to multiply, matrix A columns, the magnitude P must be the same of magnitude matrix B rows. So in this case we've got 3 columns from A and 3 rows from B. As we multiply these two sizes of matrices, as P's are the same on both sides, so we've got 3 and 3, therefore we can multiply matrices. What the m and the n gives us is the final size of the matrix. So we're going to be given a m times n matrix, which is 2 by 2, and as the inner values of 3 by 3 are the same, we can therefore multiply. So we can't multiply matrices of the same size, but if they follow this rule, where the columns of matrix A is the same size as the rows of matrix B, we can. So let's begin by multiplying this. So how do we actually multiply this? A times B. And that's going to equal a 2 by 2 matrix, as we've just established. We take the first index, which is the first row, first column. We multiply it by the first index, which is row 1, column 1. And what we do is we add the multiples of the remaining indices on the first row of matrix A plus the multiplication of the first column of matrix B. So we move to the right every time we multiply by one index, and then we move down by one index. Now this might sound confusing, but let's see how this looks. So we've got the first index, which is 1 times 2, and then what we do, we move to the right by 1 and we move down by 1 on matrix B. So we add that to get the final index value. So that's going to be 2 times 3. And again, we're going to complete this until we finish the entire row and the entire column. So that's going to be plus 3 times minus 1. So we've just gone down again. Now we've hit the end of A and B. Again, this is why they must be the same size. As we finish the row and the column at the same time. That's going to be our first index. Then what we do is we go to matrix A, we're going to move down one row, so we're going to go down to the second row. We're going to start with this minus 1, and we're going to stay with the same column. What that gives us is the second row of the final matrix. So that's going to be minus 1 times 2, plus, we move to the right one, which is 0, and again we move down 1, so that's going to be 0 times 3, plus, now we move to the right by 1 and we move down by 1, so that's going to be 1 times minus 1. Now what we do is we go back to the first row, and now we move on to the second column of matrix B, and we're going to repeat this. So that's going to be 1 times 1, plus we move to the right and we move down by 1, so we're going to be moving down now. 2 times 1 plus the final, which is 3, and we move down by 1, so 3 times 2, and again we stay on the same column and we move down to the final row, so that's going to be minus 1 times 1 plus we move to the right on matrix A, which is 0, and we move down by 1 on matrix B times 1 plus move to the right on matrix A, which is 1, and we move finally down on matrix B, which is times 2, and that equals our final. So we got, for the first index, we've got 1 times 2, which is 2, plus 2 times 3, which is 6, plus 3 times minus 1, which equals 5 in total. And then we got 1 times 1, which is 1, 2 times 1, which is 2, 3 times 2 is 6, add that up, that equals 9. 1 times 2 is minus 2, 0 times 3 is 0, 1 times minus 1 is negative 1, so that equals negative 3. And then we've got minus 1 times 1, which is negative 1, 0 times 1, which is 0, 1 times 2 is 2, add that up, we get our final matrix, which is 5, 9, minus 3, 1, and here's your final answer. So no matter what size matrix you get, you can have a matrix of 3 by 2 multiplied by a 2 by 4. So as long as the magnitude of columns of matrix A equals the magnitude of rows of matrix B, we can multiply. They are the same, therefore we can, and the final size will equal a 3 times 4 matrix. So hopefully you enjoyed that video. If you did, please smash the like button. Please do subscribe, that really helped me out, and see you guys in the next video. Take care.